This is a demonstration of the Focus 3D laser scanner and SceneVision 3D software. FARO's Focus 3D laser scanner is the most advanced 3D laser scanner available. It's compact, lightweight, blazingly fast, very easy to use, and surprisingly affordable. It's a long-range scanner with a built-in high-resolution camera, making it perfect for capturing crime, accident, and fire scenes in 3D and color. To use the Focus 3D scanner, you simply mount it on a lightweight photographer's tripod, turn it on, and hit the Start button on the simple touchscreen interface. No power cords and no external devices required. In about 2 minutes, it captures 11 million measurements in a 360-degree scan. And much higher resolution scans are possible. 28 million point scans take less than 5 minutes. Then, in just a minute or so more, it captures high-resolution photos of the scan, all automatically. The Focus 3D is a great laser scanner, and we'll work with that data in great software. ThirdTech's SceneVision 3D software is the industry's leading tool for creating, analyzing, and presenting photorealistic 3D computer graphics models of crime scenes from 3D laser data. This is a data set of a staged crime scene done in collaboration with the Justice Studies program at Methodist University in Fayetteville, North Carolina. This scene was scanned both inside and outside, and here we're looking at a 3D model of the outside of the scene, which, as you can see, we can look at from any direction. We can fly around in the scene. We can zoom in and out. What we're going to do is take a look at the data that was captured to create this scene, and a number of the steps taken to produce the model you're looking at. We'll also look at some of the functions that you can do, including measurement functions. Before we do that, let's take a look at what the inside of the scene looks like. This is a 3D model of the same house seen in the outdoor scans. You'll notice that we can again look at this from any direction. We can turn off what's called the back sides of surfaces so that we can now look inside the house very easily. You'll see that we have a person in the living room and a mannequin in the kitchen. This is a 3D model made up of many different scans. These scans began as individual laser points. Here we can see some of the points that were used to make up this model. But let's take a step further back and look at the data that was used to create this model. The first data captured by a 3D laser scanner is grayscale data, and here we see a 360-degree scan of the living room. We can zoom in on this and take a closer look. You'll notice that a great deal of detail is visible even though we have not yet applied color to the scene. The grayscale values are determined by the laser reflectance off surfaces. That is, you can get this same data whether the scene is completely dark or fully lit. Let's take a closer look at the data to see what it looks like. You might think that this is looks a lot like a black and white photo, but in fact each single point is not just a pixel, but rather it is a laser measurement. So every one of these little squares is a single laser measurement captured, And for every one of those points, we know its distance from the laser scanner, we know its azimuth heading, that is, its horizontal heading, its elevation, and the grayscale value. There's a great deal of information immediately available, and so, for example, if I wanted to know the distance from this point on the chair to the outlet on the wall, I can measure it immediately. And so we can see that distance is 4 feet 11.1 inches. Now, in addition to capturing this laser data, the 3D scanner also takes 85 photographs, and that color is automatically applied to the laser data. So let's take a look at this same data, but in color. Here you can see the image we were just looking at, but now, of course, a great deal more detail is available. And again, this is not just a photograph. This is a 360-degree scan made up of 11 million individual points. Notice that the line we measured a moment ago is also visible in this color version of the scene. So we begin with this 2D version of the data, and then there are many other ways to visualize it because it is three-dimensional. The next way we'll look at is as a 360-degree panorama of this single scan. So now, again, this is the same single scan from the laser scanner. However, we're now looking at it as a panorama. This is not yet three-dimensional, but it does give a very powerful and useful visualization of the scene that is particularly useful in court. We can look around, we can look up and down, we can zoom in and out. And because our panoramas are associated with the 3D laser data, we can measure distances in our panorama just as we could on a 3D model. So for example, again, if I want to know the distance from the mannequin's foot to this hammer, I can measure it. Now let's take this one step further and take a look at what this single laser scan looks like in 3D. This is the data from that single scan we were just looking at in two other formats. You'll notice we get a great deal of three-dimensional data from just a single scan. Let's take a look on the inside and see what kind of data we have. The scan was done right here. You'll notice that there's a great deal of missing data. That's because laser scanners cannot see through objects, and so whatever is visible from the location of the scanner will be in the scan. So you'll notice a great deal of the room is visible, but not the data, for example, behind the chair, because the laser scanner can't see through that chair. And so it is not uncommon for a crime scene to require multiple scans to capture all of the data at the scene. The Focus 3D scanner is particularly valuable for this because it's so fast. Since each of these indoor scans took only 3 minutes, we did 3 scans in this room to capture all of it, and yet that took less than 15 minutes, including setting up and moving the scan to the 3 different locations. Now let's take a look at the entire indoor model created in SceneVision 3D from Focus 3D laser data. This model comprises a number of different rooms, and we did about 10 scans from different locations to create this model. SceneVision 3D makes it extremely easy to combine multiple scans into a single 3D model. This model began as tens of millions of individual laser points, Then SceneVision 3D does something quite unique with this data compared with other laser data software. We take these points and automatically connect them into triangles forming surfaces that are triangular meshes. These surfaces then get covered with the color from the photographs, and so what you end up with is a solid model, not just a point cloud. This is a much more realistic looking model than you would see if you were simply looking at point cloud data. We can, as we mentioned earlier, look at this data from any direction. For example, here's an overhead view showing the layout of the scene. We can do measurements of many different kinds. So you've already seen point-to-point measurements. We can measure perpendicular lines. We can also do a few unique things. We can take close-up photos that were done with your own digital cameras and embed those photos correctly aligned with the laser data. So, for example, here you see a close-up of some blood stain data that was taken with a regular digital camera but is now embedded in the model. We even have functions within SceneVision 3D to do measurements on the blood stain and automatically produce blood stain trajectories based on your measurements. These close-up photos are also valuable for footprints, documents, and other marks in the scene. And that's just the beginning of what you can do in SceneVision 3D with data from a 3D laser scanner. For example, you also have a function called the Wall Wizard, which makes it extremely easy to produce the dimensions of each of the rooms in a scene. Here you can see we've already worked the Wall Wizard on each of the rooms here, and I can now turn off the data, and so now you see outlines or a diagram of this entire scene, and each one of these lines, you'll notice, has the dimensions on it. You can optionally turn those dimensions off very easily, and now you more clearly can see the diagram of this scene. We can look at this diagram from overhead. We can put it into what's called orthographic view, which is an alternative to the standard view, and then what you end up with is a very quick and easy floor plan of the scene. You can also look at this floor plan with the original data showing as well, and so now you can, for example, look at an individual room from overhead and see very clearly what was there. We'll switch back to our standard three-dimensional mode and show some of the other features. Here we've placed in the doorway of this scene something we call a viewpoint. Here a vertical line represents an officer responding to the scene. That vertical line can be made any height, and at the top of it we've placed something we call a viewpoint, which is used to show precisely what is visible by someone at the scene standing in that particular location. If I double click on this viewpoint, that's the view from that location. I can turn my head to the left and to the right. I can look up and down, but I'm stuck to that spot in the scene. So if there's any question as to what is visible from a particular location, either by a first responder or a defendant or a witness, you can easily illustrate that in court using viewpoints. Another interesting feature is to create a fly-through in preparation for going to court. For example, here we've created a few simple steps of a fly-through. We call these steps bookmarks. And now I can just double-click on this bookmark, and it will fly to a preset location. This is extremely useful for court where you want to show particular views of a scene. Now simply by pressing a key, I can move from one location to the next without using the mouse, giving a very simple and clear walkthrough of the scene. This has been used very effectively in courtroom presentations. Another feature of SceneVision is the ability to hyperlink any photo or document to points in the scene. For example, in this case, we have a close-up photo of this area of the scene, and this was hyperlinked to this spot. If I double-click on the camera icon, you can see there is a close-up photo of this wound. Similarly, in this room, we hyperlinked another photo. In this case, fingerprints found at the scene. You can hyperlink not only photos, but documents, web pages, anything at all that can be recognized by your computer. Let's go back and take a look now at the outside model once again. This model was created from 7 different outdoor scans. We did 3 scans close to the body here in order to get all views of it. So we did a scan from the right side, from the left side, and from above the head. And then the remaining 4 scans were to cover the remaining areas around the house. I'll put the model on rotate just so that we can see it move completely around the different views of the house. Just as with the data from inside the house, you can measure any distances on the exterior as well. So if I want to know the distance, for example, from his head to the front door of the house, I can begin a measuring line right here on his head, and I can start to draw it. And now I can move to where I can see the front of the house. And now I will finish the line here at the front door. And so now we've got a measurement from his head to that front door, and we can see that distance is 18 feet 11.2 inches. Lines like this can also be used very easily to show blood or bullet trajectories. In conclusion, let me just point out a few interesting features of the SceneVision 3D, Focus 3D laser scanner system. The Focus 3D is the lightest, fastest, easiest to use scanner on the market today. It's also priced significantly lower than its competitors. Coupled with SceneVision 3D, which is the only 3D scanner software specifically made for crime, fire, and accident scenes. It's not made for engineers or for surveyors. It's easy to use, produces photorealistic 3D models, and is now being used by over 60 agencies around the country and around the world. For additional information, please contact Third Tech.